Good morning, everyone. This is Vindhya from H&S Department, Assistant Professor of Chemistry, Tigala Krishna Reddy Engineering College. Yeah. So last class, I think we have discussed about what is water, hard water, soft water, and what causes hardness to the water. So let me just briefly give a review of the last class. Okay. So if you see, as we discussed earlier, there are two types of water, that is soft water and hard water. And soft water is something which gives more lather with soap. Like if you add soap to the soft water, it gives more lather. Whereas if you add soap and if it gives no lather or very little lather, then it is known as hard water. So that is a simple test done to differentiate soft water and hard water. Now, why hard water isn't giving you any lather? That is because of the presence of calcium and magnesium salts. So this reaction we have already discussed in the last class. Yeah, because it is forming this calcium stearate and magnesium stearate, hard water is not able to give you the lather. So that is happening in case of hard water. Now, if you look at hard water, we discussed that it contains calcium and magnesium ions mainly, and that is hindering the formation of lather. Okay, so hardness of the water can be defined as the presence of calcium and magnesium salts in the water. Okay, now these hardness causing salts are of different types, and this based on the salts present in the water, hardness can be classified into two types: temporary hardness and permanent hardness. So temporary hardness is the hardness which can be easily removed by boiling. This we will generally do in our day-to-day life to remove hardness. And permanent hardness is something which cannot be removed even by boiling water. So you need to design, like you need to employ few techniques to remove permanent hardness. So this temporary hardness, if you look at it, it mainly consists of bicarbonates of calcium and magnesium ions. So here you will have calcium bicarbonate and magnesium bicarbonate that can be easily removed by boiling. Okay. Whereas if you look at the permanent hardness causing salts, this hardness is mainly due to the presence of chlorides and sulfates of calcium and magnesium ions. Nitrates are also responsible for permanent hardness, but very rarely. Commonly, you will see chlorides and sulfates of calcium and magnesium ions. Okay, so generally, hardness can be defined as any, like the water consisting of hardness causing salts is known as hardness. Because of those salts, you will see the water becoming hard. To some extent, hardness should be there in the water which is potable, like in the drinking water. To some extent, hardness should be there, but presence of more hardness in the water, it is not good for consumption. Okay, so in the later classes we will discuss about what all things are necessary in the water, potable water, and what is the treatment done in the potable water. Those all we will discuss in the next class. Okay, so if you see, this is the hardness, like total hardness and the description. If it is very soft water, you will have 0 to 4 degrees hardness, soft water 5 to 8, mild 9 to 14, and if you say it is very hard, then it is above 30. If you have hardness above 30, then it is known as very hard water. Okay, and there are specific units for representing hardness. We generally represent hardness in terms of ppm, parts per million, or you also have degree clerk and degree French. Okay, so you can see these are the more commonly used salts responsible for hardness: calcium bicarbonate, magnesium bicarbonate. It is temporary hardness causing salt. And you have calcium sulfate and magnesium sulfate, which are permanent hardness causing salts. Apart from these, there are the other less common salts which will also lead to hardness. Okay, so till now we have been talking about hardness, temporary hardness and permanent hardness. Now, if a water sample is given to you, how do you estimate hardness in the water? See, generally, if you are given with a water sample, and if different salts present in the water are known, if the amount of different salts present in the water, hardness causing salts present in the water, if it is known to you, you can just calculate the hardness of the salt using degree of hardness formula. Okay, so you have a degree of hardness formula which is equal to weight of the salt by gram molecular weight of the salt into 100. So that is the hardness causing degree of hardness. Just whatever is the amount of hardness causing salt present in the water, just divide that weight with the molecular weight of the hardness causing salt and multiply it with 100, you will get directly the amount of hardness present in the given water sample. Okay. So this formula can be used when you have hardness causing salts, when the amount of hardness causing salt is known to you. If the amount of hardness causing salt is known to you, then you can use this formula directly. So, now what if just a water sample is given to you without giving you the amount of salts present in the water? If just a water sample is given to you and you are asked to calculate the amount of hardness in the present water sample, then you should employ a different technique. You should use a different technique. By using that procedure, you can calculate what is the amount of hardness present in that water sample given to you. Okay, so now with like if the amount of water sample, if the amount of salts present in the water sample is given, then you can just substitute in the formula and get the hardness. Now we are dealing with what if the amount of salt is not given. If the amount of the salts is not given, then there is a special technique used to calculate the hardness of the water. That is called as complexometric method that we are going to discuss now. Yeah. Yeah. So now let us discuss about the complexometric method of estimation of hardness. So this complexometric method is also known as EDTA titration. So in this method, just the water sample is given to you and you are going to do certain procedure, some experiment you are going to do and calculate the amount of hardness present in that sample. Okay. And as you have seen, this is also known as EDTA titration. What is EDTA? EDTA is nothing but ethylene diamine tetraacetic acid. You can see this is EDTA structure. So you have two nitrogen groups combined with four acetate groups. Two nitrogen groups combined with four acetate groups. So here if you see, the speciality of this ethylene diamine tetraacetic acid is it is hexadentate ligand. Okay, so this will mainly serve as a ligand which can arrest the metal and form a complex. We all know that when a metal and ligand combine, they will form a complex. The same principle is applied here. Your EDTA is hexadentate ligand. That means it can donate 6 lone pair of electrons to the metal ions. So here, what are the metals with which it is forming a complex? It is calcium and magnesium ions. As we all know, they are the metals, alkali and alkaline metals. So with that metals, this EDTA will form a complex and the procedure will continue. That is the main principle involved here. Okay, so two nitrogens will give you two lone pairs and four oxygens from the acetate molecules will give you four lone pairs. So totally 6 lone pairs can be donated with this EDTA. Okay, so that is called as hexadentate ligand. And why this EDTA is preferred to arrest the calcium and magnesium ions? Because EDTA is hexadentate ligand, as I said earlier. And the second point is this EDTA has one speciality that it can form a complex with different metals at different pH. Like if you just alter the pH accordingly, you can arrest different metals of our necessity. Now, because we want to form a complex with calcium and magnesium ions, EDTA has that speciality that it can form a complex with calcium and magnesium ions at a pH of 10. So if you maintain a pH of 10 in the water sample and add EDTA to it, then this EDTA can form a complex with the calcium and magnesium ions present in the water, and you can do something with that complex. So you can just calculate how much amount of complex is formed. Okay, that is one thing you should do. And second thing is, here you are doing titration. You are doing titration with the water, and because water is a colorless liquid, you should have something to detect the entry. So mainly these titrations are based on the color change. So in order to observe the color change, you are adding an indicator. In any titration, we generally add indicator. So the indicator added in this titration is areochrome black tea. This is the indicator added. So you have to maintain the pH at 10 and you need to add an indicator. The name is areochrome black. And how do you maintain a pH of 10? That is the next question. So we all know that if you want to maintain a pH, you have something called as buffer solution. Buffer solutions are the solutions which can maintain the pH at our interest. Okay, based on the what type of buffer solution you are using, that pH can be maintained. So here we need a basic buffer solution. Because pH is 10, it is a basic buffer solution. So we are using a buffer solution which is prepared by mixing ammonium chloride and ammonium hydroxide. Okay, that is called as ammonical buffer solution. If you mix equal quantity of ammonium chloride and ammonium hydroxide, ammonical buffer solution is formed. Okay, so just you should add 2 to 3 ml of that buffer solution in the sample. Then the pH of the entire sample will get converted to 10. Okay, so in EDTA method, we mainly add something to maintain the pH. Here, that is ammonical buffer solution, and you will add an indicator. Second thing is you will add an indicator. Those are the two things you will add. Now, coming back to EDTA titration. With this titration, you can determine both temporary hardness, permanent hardness, and also total hardness. All types of hardness can be determined. And if you look at EDTA, it is a complexing and chelating agent. Okay, so which is used to capture the metal ions. EDTA is a chelating agent which will capture the metal ions. So when it captures the metal ion, the water becomes soft. But the metal ions are not removed from the water. It will be there in the water, but it is arrested with the EDTA. Okay, that is one thing you should know. And here, if you want to calculate different types of hardness, different, like you have to do different titrations. A series of titrations should be done to calculate total temporary and permanent hardness. So we generally, when you do titration directly, we generally do a total hardness titration. Okay, so first first and foremost thing is you need to standardize your EDTA solution. You should prepare a EDTA solution and you need to standardize it with standard calcium carbonate solution. Take a standard calcium carbonate water and with that titrate it with EDTA. The color changes from wine red to blue. Stop the titration. These all I think you all know. So first thing is you should standardize the EDTA solution given to you. That means the amount of EDTA, the concentration of EDTA should be known first. Okay, that is the first thing. Now coming to the procedure of how you estimate the hardness of water. First thing is you take 20 ml or 50 ml of the water sample of your interest. If any, it is individual's choice. You can take either 20 ml or 50 ml of water sample in a conical flask. Okay, and to that water sample, first you need to change the pH. You should convert all the pH into 9 to 10 over a range of 9 to 10. So add ammonical buffer solution 2 to 5 ml. Okay, if you take 50 ml water sample, add 5 ml. If you take 20 ml, add 12. Okay, so depending on the amount of water sample you are taking, add the buffer solution so that the pH of the water sample is maintained at 9 to 10. Okay, and now next thing you should add is indicator. just add 1 or 2 drops of idiochrome black tea indicator. Okay, so as soon as you add idiochrome black tea indicator, the color of the water sample, which was colorless till now, once you add this indicator, the color of the water sample gets converted into wine red color. You can see, I think this you have it in your lab. While performing the experiment, you can observe these changes. We have this experiment in the lab. In the laboratory also, you will do this experiment. So it will get converted into wine red color. Why this is happening? Why the color is getting converted into wine? Because, see, in water you have hardness causing salts. That is calcium and magnesium salts. Yeah, calcium and magnesium salts are present in the water. Now, our aim is to find out amount of these salts present in the water. That is hardness of the water you're going to calculate. Okay. Now, as soon as you add this with EBT indicator, what happens is this EBT will form a complex with these calcium and magnesium ions. You can see the reaction. It is forming calcium EBT or magnesium EBT complex. Now, these calcium and magnesium ions are not happy with this EBT indicator. It is not happy to stay in that state, in that complex form. So, this complex, I can say it is an unstable complex. Unstable means these both EBT, calcium and magnesium ions, they are not happy being together. That is the unstable complex. Okay, and the color of this complex is wine red. So now your calcium and magnesium ions will be ready to gain the stability. Once it uh, have that molecule of its interest, it will immediately leave this EBT and it will form a complex with that molecule. Okay, so now this is an unstable complex and this complex is wine red in color. Okay, now what you do is, now your conical flask, the solution, the water color got changed to wine red. That wine red color is because of the formation of complex with EBT indicator, that to an unstable complex. Okay. Now, before doing this only, you have to fill the burette with EDTA and keep it ready. Okay. Fill the burette with EDTA and keep it ready. Now, after color changes to wine red, what you do is slowly start adding EDTA drop wise from the burette into the conical flask. And while you are adding into the conical flask, you need to titrate it like this. You need to mix it. So that what happens is, now I said this is unstable. The complex is unstable with EBT indicator. So your calcium and magnesium immediately, as soon as you start adding EDTA, your calcium and magnesium ions will leave EBT into the solution and it will form a complex with EDT. You can see here. Buffer is already added. So your pH of the water sample is 9 to 10 and your EDTA will form the complex with only calcium and magnesium ions at that pH. So once you add EDTA, your calcium and magnesium ions will leave EBT indicator into the solution and it will get complex with a EDTA. And this EDTA calcium or magnesium EDTA complex, they are very, very, very stable complex. Once it is formed, it will not dissociate again. Okay. So like that, until all the calcium and magnesium ions will get replaced with EDTA, the reaction continues. You should keep adding EDTA from the burette into the conical flask and all the calcium and magnesium ions will form a complex with EDTA. Okay. Once the complex formation is completed, once the calcium and magnesium ions in the water is finished, all the ions form complex with the EDTA. Once it is done, the color which was wine red initially, it will suddenly get converted into blue color, steel blue color. Okay, the color changes from wine red to blue color. So that means once blue color is seen in the water, permanent blue color, I'm telling you again, once permanent blue color is seen in the water, you have to stop titrating. That means all calcium and magnesium ions are forming, are like they have formed complex with EDTA. So if you add extra EDTA, it will just be in the solution. You don't have any calcium and magnesium ions. So that is why, in order to calculate exact amount of hardness. Once the color changes from wine red to blue, you need to stop titrating. Okay, so stop the titration and note down the end. So just see how much amount of EDTA is consumed to completely form complex with 20 ml or 50 ml of calcium and magnesium ions. That is hard water. Okay, so just check that and note down the reading. So generally, we will do this titration 3 times. Once you get blue color, repeat the titration again. So like that, you have to do 3 times. Again, take 20 ml of water, add indicator and buffer solution into the water and titrate it with EDT. So until you get consecutive readings, 2 same consecutive readings, you need to do the titration in order to avoid any errors. Okay. So once you get the amount of EDTA consumed, I think from here you can easily calculate the amount of hardness present. Okay, how do you calculate the amount of hardness present? We already know that, see, this is the formula you have to take it. M1V1 is equal to M2V2. Okay, so molarity of hard water. First solution I am taking it as hard water, second solution I am taking it as EDT. Okay, so M2, we already know that value. We have standardized EDTA already, so you will know this value. And V2 is the volume of EDTA consumed. Whatever volume you have seen in the burette endpoint, that is your V2. V1 is 20 ml of hard water we have taken, and M1 is the molarity of the hard water. This you have to find. Okay, so M1 is equal to M2V2 by V1. Just substitute all the values and you will get the molarity of hard water. So after you get the molarity of hard water, you have to calculate the hardness. This is a formula. Hardness is equal to molarity of hard water into 1000 into 100. 1000 into 100 is written as 10 power 5 here. So why we are multiplying it with 1000 and 100? See, we are multiplying it with 1000 because molarity, if you look at the units of molarity, it is grams per liter. Molarity of units is grams per liter. But when we calculate the hardness units is always milligrams per liter. It is not grams per liter. It is very minute amount. So we calculate in terms of milligrams per liter or ppm. Both mean the same. So in order to convert grams into milligrams, we are multiplying this molarity into 1000. So in that way, you will convert grams into milligrams. Okay. So that is 1000. And again, you should multiply it with 100. Why? Because, see, this is the reason. Always the hardness of any water sample should be calculated in terms of calcium carbonate equivalence. That is a rule. That is the thing which is already specified. So in order to convert the hardness, whatever molarity you got here, in order to convert that in terms of calcium carbonate equivalence, you have to multiply it with 100 because 100 is the molecular weight of calcium carbonate. Okay, this is generally done because 100 is a standard number, so you can do the calculations very easy. That is one reason. And second reason is whatever calcium carbonate salt is formed, it is the most insoluble salt and it can be completely precipitated in water. So because of these two reasons, always the hardness is calculated in terms of calcium carbonate equivalence. Okay, so for doing this, whatever molarity you get here in milligrams per liter, that should be multiplied with 100. So 1000 into 100, instead of that, here it is given as 10 power 5. Both mean the same. Okay, so that value is the hardness of the water sample given to you, and that will be in ppm. Okay, so in this way, if you calculate the amount of hardness in the water sample given, you are going to calculate the total hardness. Whatever hardness you get here, that is the total hardness of the water sample. Now, you want even to calculate permanent and temporary hardness. So what you have to do is after calculating, after doing till this step, whatever total hardness you get here, calculate and keep it aside. Now take the same water sample which you have taken for total hardness calculation. Take the same water sample and heat it. You have to heat the water. Okay. Once you boil the water, We already discussed in the starting of the class that temporary hardness can be removed by boiling. So when you boil water for some time, whatever temporary hardness causing salts are there, they will get precipitated. Okay, so after boiling water for some time, just filter the water. So the temporary hardness salts can be removed with the precipitate. Okay, so clean water, clear water, whatever you got after filtration, that contains only permanent hardness causing salts. Okay, now repeat the experiment with that water sample after filtration. Whatever water you get, with that water, you do the same titration, EDTA titration. Add buffer, indicator, and then titrate it with EDTA. So once you get, so same EDTA, how much you do the titration until the color changes from wine red to blue color. Okay, so remember now after boiling, you have only permanent hardness causing salts in the water. Okay, so do the same calculations with the formulas, do the same calculations, and now whatever hardness you are getting here, that is the permanent hardness. Okay, because temporary hardness causing salts we have already removed. So that is a permanent hardness. So you already got total hardness in the first step, and in the second titration, you got the permanent hardness. Now we know that total hardness is equal to permanent hardness plus temporary hardness. So from this, substitute total hardness and permanent hardness, you can easily calculate temporary hardness. Okay, so by doing titration twice with and without boiling, you can calculate temporary and permanent hardness also. Okay, so now while doing this experiment, you need to take care of few things. Yeah, safety considerations. What are the things you should take care of? One is keep the pH 10 buffer in the hood. We generally like perform this experiment in a wood because whatever buffer we are using here is ammonical buffer solution, and its vapors will cause certain breathing problems. So you need to add buffer only in the wood. That is one thing. Second point is when you are dealing with the indicator, it will stain your dresses. Like once you get that mark on the dress, it will not leave. So idiochrome black tea will stain your dress as well as your skin also. So be very careful. Add only with the dropper idiochrome black tea. Don't play with that idiochrome black tea. That is one thing. Second thing is all the waste materials while doing the experiment, you have to safely rinse them in the sink. Okay, don't play while doing chemistry experiments. That is one thing. Okay, and these are the things you should take care of while doing this experiment. And the best part of this experiment is just by simple titration, you can easily calculate like total, permanent, and temporary hardness in the given water sample. Even if you don't know what type of salts are present and how much amount of salts are present, even if you don't know all these things also, you can very easily calculate amount of hardness present in the water sample. Okay, and it's very simple also. This experiment we will do it in the upcoming lab, and you will understand this very clearly that. Okay, now based on this topic, Nana, you will also have the problems. If you get this question, you will definitely get a problem along with this question. Okay, so while doing this questions, please do it orderly. Like first read the first part of the question, whatever like you can calculate from that things given. First calculate that and just write down neatly what is M1, what is V1, what is M2, what is V2, next M3, V3, next M4, V4. Because as the titrations increase, don't give the same number. If you give the same number, you'll get confused. So just uh, change the numbers and do the calculations like in an order so that you will not have any confusions and you will not have any difficulty in solving these problems. It's very easy. In the next class, we are going to solve these problems. Okay. And as you all know, we have different types of units for hardness. Once you estimate the hardness, next thing you have to do is you have to give some thing after that number. You can't just leave the number like that. So these are the different units of hardness: parts per million, milligrams per liter, degree clerk, and degree French. These are the four different units. So generally, we calculate hardness. See, whatever calculations I have done, I have explained now. we generally get hardness in these two units, parts per million and milligrams per liter. These both are equal. So both are same, ppm and mg per liter. And if you want to convert ppm and milligrams per liter into different units, that is degree Clerk and degree French, then you need to know this relation. See, this is a relation you need to know. 1 ppm is equal to 1 mg per liter. This I said they both are equal. So 1 ppm is equal to 1 mg per liter, that is equal to 0.1 degree French, that is equal to 0.07 degree Clerk. So with this relation, you can convert hardness. After estimating the hardness, you can convert hardness into different units if asked. Generally in problems, they are going to ask you. Calculate the hardness in degree Clerk or in degree French. So first, you calculate the hardness in ppm only first. Whatever method I have explained, with that method you calculate it in ppm or mg per liter and then convert. Just multiply it with 0.1, you will get degree French. Multiply it with 0.07, you will get degree French. So based on this relation, we can calculate in any units asked. Okay. So that is all for today, Nana. I hope you all understood how to calculate the amount of hardness present in the water sample. If if the amount of salts is given, just calculate with degree of hardness formula. If it is not given, you have complexometric titration, because with EDTA you can easily find out that we have discussed today. I hope you all understood, and if you have any doubts, please ask me in the next class. Go through the topic and ask me in the next class. And in the next class, we are going to solve problems based on this topic. Okay? Yeah. Thank you. Thank you all.